Lars-Inge is my name, and yeah, I've been through this with Gapwaves now since 2015 almost. So I wanted to share a little bit with you about where we are with the company and what is really happening in such thing as coming from a Chalmers invention, as we're talking about here, to be coming something interesting for customers on a global market. So this is what I'm trying to explain for you, and of course there will be some question and answers afterwards, I understood. So please keep your questions up to take them after the presentation. Okay. One thing in the company here is that we have a quite broad vision. It's to be the most innovative provider of millimeter wave antenna systems and the preferred partner to those pioneering next generation wireless technology. This was not ready from the beginning. That's something we have been working out over the time. We are working with more and more people in the company, of course, but this is also important to say that having a vision is always very important, and it should be quite far away, not easy to catch, because then it's a goal more. So vision is something, yeah, where you really want to be in the future, and no date for it, so to say. I was planning to share a video with you, but I think we dropped that today because I think there will be not enough time really to go through that. Talking a little bit about this commercial breakthrough we have in this company. What is Gapwaves? Yeah. Yes, Gapwaves is a company who has been started from the founder Per-Simon Kildal. He was a professor at Chalmers University. Here, just behind me, I would say, because we are now quite close to Chalmers, south of Liseberg. And Per-Simon was working with electro on the E division at Chalmers for many years, and he was well known on the global screen already with his, he was normally keynote speaker, etc., on big events around antennas. So he was quite known as a researcher and inventor all over the globe before I went into this. And important to know, he had one very interesting invention he was very proud of, and that was the gap technology. And that's what we have based his company on. And going forward, what we have done, to make it happen, we need to finance the business. So we went public already in 2016 with an IPO on the Nasdaq First North in Stockholm. And at that time, we had a share value or a company value of 50 million when we entered into the stock market. Today, we are in the 160 million euros as a market cap and have more than 8,000 shareholders. So we have become a quite popular share on the market as well. And there are many people who are believing in what we are doing. And yeah, I think it's quite easy to understand what this company is about. And antennas, just to say that. Antennas is something you always need to transfer information out or into a radio. And everything on the wireless side on the earth is always passing antennas, I will say. Both when it leaves a radio and when it comes back to a radio. So all communication is always integrating an antenna in some sense. So there are many of them already on the earth, and there will be a lot more in the future. One important thing Per-Simon was very good at, he patented our technology quite early, and that happened already in 2009. And it's important to have as a security and really have some kind of evidence that this is really our idea, and that's something we want to build a company on. And from there, we have, of course, made a number of new patents. I heard from my team here yesterday that we were up in 30 patent families currently. So that's something which we grow all the time to keep as much as possible for ourselves, not easy to copy for any other company. Specialized today, we are in two areas mostly. Of course, it's about millimeter wave. I will come back to what that is later on. But it's in the area of antenna solutions for telecommunication. but also for automotive radar. We started mostly with telecom, but has been more and more focused on automotive. And the reason is that as higher frequencies, more important to have a good antenna technology in this kind of waveguide antennas. And the technique we do have is unique in the sense that we can manufacture these things in high volumes. And it's a mechanical piece we really deliver in the end. So it's not an electronic chip only, it's really something which can be made in a plastic molding solution or some milling machines, etc. And today we have 30 people employed in the company. I hope you can hear me well, so I don't hear anything else, so hopefully it works. Going from an invention to a commercial breakthrough is really not as easy as you can think. There is a number of steps on the way, of course. But I think it's the most important part is really to understand and see the idea, how unique is it and what kind of problem you can solve with such idea or invention. We did know quite early that the gap technology was quite amazing. It was really a big step in the area of radio communication or radio wave propagation. And that has been, so to say, knowledge on the research arena early, but it's not the same as having it commercial, because it's a big step in between the researchers and the real product development and the product which is sold on the market. In our case, we also saw that we had a good thing around it, that it was possible to produce this stuff with classical production methods. So you don't need really to make some new kind of production methods. That's also important to have in mind if you should make it a global thing or it come to a big market. Next step is always important, and that's really to have financing. It is costly to take things from a research level into the next product level, being able to sell something to a customer. I would say it's more than 90% left after you have made an invention ready for in a lab on the Chalmers, for example. Another part, believe in your idea and stick to your plan. This is, you have heard them before, but really important is that you must believe in it yourself, your company, your colleagues. What you are doing is something you really need to understand and believe in, because it's always almost impossible to get in other people, financing people or marketing people or whatever on customer side. If you don't fully believe in your idea yourself, you should not run the race, I would say, because then you will not be able to come there. The market, of course, that's another important part, which normally is not so well investigated from the researcher side. So it's important to quite early get out there and understand where can I sell this type of product and what kind of customer is really the customer. In our case, we started to go for telecom, and we started with telecom companies such as Ericsson, etc. Of course, they were interested and they understood what we can do for them. When we went to the automotive industry, we started with the OEMs, typically, like Volvo Cars. But in this case, Volvo Cars is not really buying an antenna for a radar sensor, because they will buy that from some tier 1 supplier to them. So they are pointed out that we should talk to companies like Continental, Bosch, etc., who really are suppliers of radar sensors. So it's important to find where is your customer really that you can sell your product or your technology. And from that point of view, we have then been investigating and also very clearly also focused to find all these kind of companies who really can buy things from us. So we understand the market volume, but not only that, we also need to understand if we can make sense in their technology or in their sensor or in their radio communication equipment. And that's a little bit about the next bullet here, then finding your position in the value chain. So you know where you can sell things and where you can make difference with your products. I also want to compliment that Gothenburg, in our case, has been a very good ecosystem, because here is a number of people really knowing the millimeter wave and technology, and that's important in our case anyway. So we find Gothenburg as a very nice place to be, because here we can find the competence for what kind of people we need. And still we work quite hardly together with Chalmers also, because that has continued. Of course, it's important to even have the next kind of invention on the table for us in the future, because this is always something which is going on all the time. It's not a journey which stops one day. You need to be on that journey all the time. So there are, of course, challenges on the road. It is time consuming and costly to how the technology to make them most different. It's really important to understand that I say time consuming and costly in many sentences here, and that's the reason, because you always underestimate what really has to be done. That's very easy to do, and yeah, it's better to know that there is a need for a lot of money, but also a lot of time and good people to make it happen. So you can always fix it, but it is a quite big portion of, you have to be brave, you have to be what you call envis in Swedish, and because otherwise you can lose your faith and don't really go the full way. And it's absolutely what you need to do. And it could be some days that you think it's better I stay in bed, but don't do that, because you will always be better if you are working all the time. A little bit more about the technology as such, just giving you a brief overview. The Gapwave technology we do have is about how to make what we call waveguide solutions for radio communication or radio antennas. And in our case, you can see here we have a small plate, and under that plate we do have a pin structure and also what we call a waveguide. That's the line here. And the thing here is that we can use this kind of structure, which is called a meta surface with these pins, as a wall instead of having metal walls around our waveguide. And this makes it quite easy to assemble and also to produce. So it is very much about how really to make products from these kind of structures instead of having the classical waveguide structure, which you can see here. The golden thing on the top in this diagram is rectangular waveguide as it looks normally in a lab. And it's a full metal tube, and you need to have it very, very homogeneous, because otherwise you will lose your waves. And this is typical something people in the RF millimeter wave arena is very well aware of, but it's not so easy to understand that you can make these walls by just having pins. You can look through your structure and still you don't lose the waves. You can still control them in a good way. And this is really a little bit amazing really for many people when they realize this is working, because you don't believe in it when you see it first time. As an engineer, I will say. So classically, every antenna is made by a PCB solution normally. That's the most common thing you see on the market in most products. But going to waveguide is really because you need to go down in losses. But when you go up in frequencies, like here, you see the frequency bands used today for 2D, 3G, 4G, etc. We are on quite low frequencies if you compare to millimeter wave. Up to 3.5 gigahertz is what we call mid-band today, which is the first band for 5G. But really, if you need more performance, you have to go up in frequencies like to 28, which is something we have in some markets today for example, in US, and it will come also in Europe the coming years. But you also see here that having a radar sensor in a car, there is a global standard for that kind of frequency, and it's 77 gigahertz. And that's quite high. And what happens when you go from these lower frequencies to higher frequencies, really that the losses decrease dramatically. So you don't really have no signal coming out from your antenna if you don't have a waveguide structure antenna instead, because then you have almost no losses. So you can have the full power out from your radio all the time. So at higher frequencies, our technology make more sense. So we are more and more important over time with our technique, that's for sure. Some of the products we work with today in the automotive radar market, there is typically something like 80 million radars produced per year at the moment, and that's something which will grow dramatically over some years now, because there will be more radars in each car, and that's really for safety reasons mostly. And here you on the left, you see our typical antenna for an automotive radar. It's a small piece, but it's very well performing, and it makes sense really for the customers in this area, both on the side of cost, but also on the side of performance, of course. So we beat them quite well here if you look at the classical patch antennas. On the 5G telecom, most things still are running on lower frequencies, but we see that there is a demand for going up to 28 or higher frequencies also in this area. And then you can see this kind of product we have made here for 28 gigahertz. It's a repeater we have made for one American company who is in that market. And we also work with some other customers on that side with like repeaters, but also this kind of in-house 5G connection, which will be maybe the next version of Wi-Fi, etc. as well, because we are using more and more of our Wi-Fi also inside, not only outside. So it's important that we can really broaden and have more power internal in-house as well. Another part we have picked up the latest year mostly is around new verticals. In these cases, we are talking about last mile delivery stuff. That's something very important for that market to automate and have autonomous driving on small kind of robots delivering packages, etc. It could be also drones, etc. In these cases, we have mostly worked with what we call an imaging radar. And we also have a number of customers in that area today asking for antennas for their products. The interesting thing here is that is not really a market of today so much. In the automotive radar, we do really have big volumes already. But in the new vertical, we see that it's growing quickly, but will also come up with a number of new players in that. So it's relatively interesting for us to be there. Here you see a typical automotive radar solution and what we can make in difference on that side. One customer made a statement to us quite early and said that we gain what they call 5 dB when we have our antennas instead of the patch antenna. And 5 dB, if you know anything about decibel scale, it's quite a lot really for talking about performance in this case. So they are more than happy, I can tell you. And they really ask for this, all of them today. So it's a trend going from classical patch antennas to waveguide antennas in the automotive radar industry. The 5G, typically we solve, of course, problems here as well. And you can see here, what can you do when you have better performance? Yes, you can have longer range for communication. If you have a base station, you can go maybe up to 1 kilometers or something. But we also have to understand that when you are on 28 gigahertz, the waves will not go around things or have any reflections. So you need to have what we call line of sight. So anyway, even if you can have more performance, you also need to have an understanding of that the line of sight problem is coming more and more when you go up in frequency. So the buildings are, of course, in the way for the wave. So it might be that we will sell this kind of equipment like repeaters more in the beginning anyway, but this will grow over time. Real 5G, in my word, is really having what we call a gigabit performance in your telephone. So you can have as better than you have on your home TV or fiber at home directly into these kind of devices. That will be the next step for 5G, I would say. And there we are a part of it. Today, here you see some of our customers we are working with. In the middle, we have already established quite a lot customer, but there is, of course, a number of them on both sides. You see on the left, typically automotive companies doing radar sensors. You have Continental, Magna, Aptiv, Bosch, etc., and Hella. These kind of companies are quite big, I would say. Many of them are bigger than Volvo Cars, for example. So we are playing with big companies, and that's really a demanding thing to handle for a small company such as Gapwaves. But I think we do well here, and we do really have something which they like and want to buy from us. On the other side, you see the market for the telecom. Typically, there you have only 5 companies on the earth doing the radio base station equipment for most of the operators. Because in that sense, Ericsson, Huawei, Nokia, Samsung are making what they call the infrastructure build sets for the operators. And the operators is really investing, like Telia, Nokia, Telia and Telenor, etc., or in Sweden are doing typically the investments in this kind of equipment. But we only make what we call in this area the antenna, and it's always a part of this big system integrators work. So we have to find a way to work together with them, of course, because we don't make a full base station. That's a little bit too much for Gapwaves yet. And in the middle, you see that we do really have a number of customers working with us, both in the area of the new verticals like Under here, are doing something for the last mile delivery product. Veoneer is one of the tier ones in the automotive radar, and they have our technology inside today. ZF is another one, also in the automotive segment. And then we also have some undisclosed customer we can't tell the name of because that's they are not allow us to talk about them. And it's all both in the automotive, but it's also in the tech giant cluster in US. So we really have interesting, very demanding big customers on our screen today. And yeah, it's a tough demand for us or challenge to work with these kind of very big companies, and they see something very interesting in our technique. Otherwise, they will never come to a small company as us asking for it, really, because this is the case. And it's fantastic, funny to be the leader for this very good team we have here. The competence around me is, of course, one of the most important part, because I'm just a civil engineer from Chalmers from 82. I don't really have the engineering in the electrical field on my shoulder before, but I do have quite a lot of the market knowledge and how to make big deals with big customers. So that's my most important part in my job here, and also to convince both the finance or investors so we get money for what we are doing, and also convince the customers. So in a combination, the team is really important to build a company as this. So if I try to summarize a little bit about what I've talked about, Gapwaves, I think you understand we are a small company. It's coming from an invention Per-Simon Kildal was quite clever in that sense. He really made some smart steps, and this was his biggest invention in his life. So I'm very proud that I can bring that to the market and make something important of it, because that was his will, so to say. But coming to the invention or the idea, that solves a problem. That's an important part, really, when you start this kind of journey. If you don't believe in it fully, you should not maybe, or you should maybe investigate better before you start this kind of journey. And I say here, dare to believe in your idea. If you don't do that, who should believe you, or who should you try to convince if you don't believe in it yourself? Never try that, because that will never, you will never be successful in that sense. And who is the customer? That's a very important question you need to put on the table quite early. And if it's on a global market you are trying to reach, you have to find out who really should pay your bills in the future. Because if you don't know that, or you don't find that, it will never happen. So it's important to really focus on the customer side as well. Maybe I should put this one a little bit higher, secure the financing, because without money, you will have the wrong focus all the time. This needs money, because if you don't have money and the people behind you, you can build up this company, kind of company. You will never be successful. It's very hard, and it's a lot of work you need to do. And then you need to have good people around you. And that also is costly over time, because the customers will not pay you the day one. They will pay you in the future when they see that this really makes sense for them. And I also said that you can't be best on everything. You have to build a team, having experts. There could be consultants from different companies. You can have advisors as lawyers, etc., helping you with such things. But you need to have a good team. You have to trust them, and you have to build the enthusiasm around the company. So you understand that there is really a willingness to walk the extra mile, ready to deliver every day, because that's needed here. And the working and the keep on working, we also say is important, because you are not ready. When you think you have made one deal with your customer, you are not really ready, and there is not really an end. You need to always be developing the company every day. That's really important to be successful. That's my belief. We are not, as a company, Gapwaves in this sense, ready for everything, because we don't have a positive cash flow yet. And that will take some more time before that happened. But I'm really sleeping well in the night, because as we have here, we have a very, very interesting technology. We have customers who really believes in what we are doing. We have also investors who also believes fully in what we are doing. And these elements together makes what we can see growing every day in this company. So I think I stop there. And if you want to look a little bit more about what we are doing, you can, of course, visit our home page, but also follow us on Instagram, YouTube, or Twitter. We are also on LinkedIn if you want to see what's happening on that side. So I think that was what I want to tell you now.